Alright, welcome to my video about exponential functions. If you have your work text handy, these explorations can be found on page 189. We'll walk through these really quick. So what happens whenever you're trying to plot points? I'm going to do this with a calculator, then progressively show you how to do it by hand. Alright, so what's going to happen is I can type this function into my Desmos calculator, y equals 16 parentheses 2 close parentheses. There is a button on your calculator that is a to the b. You'll tap that to the x power. Alright, next up, I can actually get this table by clicking on this edit list button, which is this little gear symbol, and then selecting convert to a table. Alright, now it does go ahead and give me a lot of the values I was interested in. So at 0, this is 16. And then at 1, it goes to 32. And at 2, it goes to 64. Now you can simply just go ahead and tap on the table and ask for 3, which is 128. You can ask for 4, which is 256. And you could actually do this by hand, though. Let me point that out. 16 is our initial value, then we're multiplying by 2 each time. So we're multiplying by 2 on every single round. If I multiply 256 by 2, I'd get 512. Now really quick, this graph goes up as you're going from left to right. This is referred to as exponential growth. 0, 16 is the easiest point to always find on these because that's your initial amount from right here. So it does hit at 0, 16 and it arcs up from there. Alright, that's exponential growth. As I've already said, you'll want to make a note about that. Now, similar to that, because it's still exponential, is going to be the exponential decay. So I'm actually going to do this one by hand, even though you could use the calculator. 16 is our first value, so when x equals 0, you do have 16. But here, we're actually going to be multiplying by 1/2 each time. So half of 16 is 8. And then, like I said, multiply by half again. Half of 8 is 4. And then half of 4 is 2. Half of 2 is 1. Half of 1 is 1/2. Alright, now what would happen is, and if you used your Desmos calculator, you'll already have seen this, but when it hits at 0, 16, what's happening on this one, every time you go to the right, it gets cut in half. So 1, 8, and so forth. It'll actually curve downward, getting closer and closer to the x-axis. It actually never does actually intersect the x-axis. So keep that in mind, that the x-axis is what's called an asymptote. This is exponential decay. If you're wondering, well, what makes one exponential growth and the other exponential decay? Well, that's simply the value of b that you have on it. So when I look over at page 191 and see my core concepts, on the first one, the value of b was greater than 1 because the value of b was 2. So we had exponential growth. So if y equals a times b to the x and b is greater than 1, you're experiencing exponential growth where it's going to go up from left to right. Now, the other one was when b was between 0 and 1. b was less than 1. It was 1/2. So that was an example of exponential decay. Alright, next thing we're going to do is determine whether each of these tables, this is on page 192, practice A, we're going to determine if these represent exponential growth or exponential decay. Let's go ahead and get started. So on this table, we're going to actually go ahead and find out the pattern from 8 to 4, from 4 to 2, from 2 to 1, and what you're going to say is multiplying by a half. If you were tempted to say dividing by 2, ignore division, only consider multiplication. It's very helpful. All right, so because it was multiplying every time, it is exponential. If it's ever just adding or subtracting or doing something else, it's not exponential. This particular one is exponential decay because these values were getting lower. And we also know that the growth factor, decay factor B was less than 1. All right, let's take a look at number 2. So from 3 to 7, 7 goes to 11, 11 goes to 15. This is not multiplication. This is simply adding 4 every time. So since it's adding 4, it is neither exponential growth nor is it exponential decay. It's not exponential would be my answer. It's only exponential when it's multiplying each time by value. All right, so on the number 3 here, we're subtracting by 3 each time is what's going on. So because it's not multiplication, yet again, I have neither as my answer. And going on to number 4, here we go from 1/8 to 1/2, from 1/2 to 2, from 2 to 8. That might be a little tricky for you, but that's actually multiplying by 4 each time. So this is exponential, but it is not exponential decay like it was back on number 1 because the value of B is greater than 1. This is exponential growth. And it's impossible for it to be equal to 1 because the B cannot be 1 with these kinds of functions. That's a rule. So now I'm going on to number 8, and I'm going to go ahead and graph these. Now you could use your Desmos calculator. You are allowed to do that, so use it if you feel more comfortable with using it. But I am going to do this by hand. If I'm doing this one by hand, the first thing I'm going to do is rewrite this -2 to the x as -1 times 2 to the x. That way it's in the form a times b to the x. My a tells me my y-intercept, so 0, -1 is my y-intercept according to that. Now every time I go to the right 1 unit, I'm multiplying by 2. So multiply -1 by 2, it'll be -2. So right 1, so 1, -2. So I'm going to go to the right again, over to 2, and I'm going to multiply by 2 again. So this was 1, -2. -2 times 2, -4. 1, 2, 3, 4. 2, -4. If this is confusing you, again, use the Desmos calculator. The next one would be 3, -8 because we're multiplying by 2 yet again. If ever you wanted to go to the left, you would simply just divide by 2. So -1/2. All right, there's a pretty decent graph, but the easiest value to always find is your y-intercept. It's the a value. So on the last one for this section, we're going to actually see that 2 is my y-intercept, so 0, 2. Again, easiest point for you to come up with. Every time we go to the right, we're going to multiply that y value by 1/4. So 1/4 of 2 is 1/2, so 1, 1/2. And then if I multiply 1/2 by 1/4, I get 1/8, so 2, 1/8. And what's going to happen here is these values are just going to get closer and closer and closer. Now going back to the y-intercept, 0, 2. If I went to the left one, I'm going to multiply by 4 instead. So it would be up here at -1/8. And there we go. Now the assignment for this is multiple choice, so you don't have to worry about making a pretty graph. You just have to be able to choose the appropriate one. And again, I would highly suggest you using your Desmos calculator to help you with that. All right, folks, thanks for watching, and let me know if you've got any questions.